everybody. How you guys doing? All right, I'm Matt Kanai. I'm a senior environment artist at Hi-Rez Studios and creative art director on a new project called Untitled Chapter, and that's mostly what we'll be talking about. And the main topic, white shoes and the middle. Basically, I'm just going to go through a bunch of systems and kind of look at how we're setting things up, and most importantly, how easy it is, because it is super easy, relatively speaking. I've used this game. Originally, our game was in UDK, and literally the second it came out, I took a couple days off. I was like, all right, gotta learn all of the Unreal 4 as fast as I can and see. And immediately, it was like unanimous to move our game over, which really didn't take that long. It took about 2 weeks to re-import everything and set everything up. Say one of the first things, blueprints, I'd say probably one of the things that have gotten the most attention. That's everyone's feeling like, oh, no script anymore, it's all visual and it's all awesome. And basically, you can use it for all of the things. How many of you guys have used Kismet and UDK or any visual scripting before? So if you get completely lost, you have no idea what I'm talking about, raise your hand. Can you please just help me explain what's going on so I understand? I'd be happy to. Just throw the hand up. So, blueprints, if you've used Unreal before, the way I interpreted them is it's kind of like taking archetypes, Unreal Script, Kismet, and code, and combining it into one magical visual thing that you don't really have to know code to make a game. And Epic's done a great job of releasing samples and a lot of templates that can get you started. So if you know what genre you want your game to be, you can basically download a template and have the camera set up and everything right away. For Hanako, we're a third-person game, so basically we use a third-person template and immediately have our camera. And one of the things, previously what you'd have to do is you'd have to code your camera, you'd have to code all of that stuff, the positioning and all of that. And here, the camera just exists in the 3D space that you can place, which is not necessarily a huge deal unless you don't have programmers or you have limited programming space. And it's really great for iteration because you can just move the camera wherever you want, set it up, tweak it, and immediately go see how it looks. So, and a lot of times you can actually do it real time. So if I had multiple monitors, it would be easier for me to show. But basically, you can move the camera and immediately see like updating game. You recompile and it just updates. And your collision box, all the things that you used to have to code. If you've used Unreal Script, it was the magical default properties section of your script, where you would set up kind of your collision box and what weapons the dude has and kind of the basics of your character. So, and from there also you have this huge list of properties that this is also, most of this other stuff that would be in default properties too. So when you're designing your games and you're working through kind of your game balance, you kind of have everything here. So you have your health and your armor and like your run speeds and all of that stuff. So you can really, the magic here is your iteration time before prototyping your game. So if you're a student, this is pivotal really, because you're like, all right, your professor will tell you, all right, you have a week to like make a game and figure it out, or whatever. I don't know. We'll go with a week to figure it out, and you have to make a simple side score or whatever. You can tweak all your variables and all of your simple mechanics very easily. So let's just do this. So here's one of our dudes running around. When I get to the animation system, that's, to me, that's kind of the bread and butter. It's a significant improvement over any animation system I've ever used in any other engine. It's awesome. So let's say, for instance, that I didn't like where the camera is. Let's move it way back. 5 seconds, have a new camera to test. Whereas before, you have to change the variables in code, compile code, wait for it to compile, relaunch the editor, and then be like, oh, that didn't work. And then close it and rinse and repeat until you get it right. Here, you can just keep tweaking, basically click compile and just relaunch and see the change. So to give you guys a little bit of a demo, there's a few mechanics that we set up that were super basic, but they were easy nonetheless. Should have set up first. Basically, I was sitting up late working one night, and I realized we didn't have a use mechanic, and I wondered, is there a way that I can make a use mechanic without emailing my programmers at 1 in the morning? Like, hey, I want a use mechanic, but I don't really want to wait for it. I don't really want to wait for you guys. I know you hate when I do that, but I'm gonna make a use mechanic. So, and then I also knew that, hey, we're a multiplayer game, so I want the use to replicate. So when I press use on something in the game, the other players know the action was taken. So it's just a really simple setup. And the cool thing is, before, to set up, you'd have to hand code your custom actions. And here I can go to input, and I can literally just set up my keybinds from in here and just make a new action. Like, all right, use or meditation or whatever custom mechanic you might have, like set other people on fire or whatever the mechanic of choice is. So to set up this little script, and basically all that needs to happen with this is just booleans changing. It's simple, like, are you using or are you not using? And then it lets everyone else know that I'm using, and I can set other things from there. So one of the litmus tests that I had for that was I wanted this asset's become infamous on the dev stream for this, but basically I wanted to be able to ring this gong, have it play an animation and a sound whenever I press use. So I set up this script in here that handles kind of it interacts with the use mechanic. It says, all right, this player's using this, now check to see if he's colliding with the trigger volume that's there, and then play the sound, but make sure that no one else can play the sound too. Go down. In a tree. All right. I got a Mario over here really quick. So while I'm Marioing over here, any questions so far? Or any like, how do you do this? What's happening? Yes?
Well, I saw you showed how easy it was to change the camera. How easy would it be to like select your variable and control like this roll or something?
I'm gonna say it's easy. Like, I don't have this set up like off the top of my head. I know how I would do it if I would start to. If I have time, maybe I'll try to set it up. But basically, like, you can make a variable for anything, and most of the time, there's probably a function in blueprints. Zach, feel free to chime in if there's already one. You could probably drop in your camera Z offset or whatever and have a variable for it that plugs straight in and change that. I'm sure you could probably change it dynamically too on the fly.
I actually missed the question. What was it?
If you could set up a variable to, can you repeat your question verbatim?
Yeah,
Without all
you
the details.
set it to where you could like add a variable to the camera's distance, set it to like the scroll wheel on the mouse or something.
Oh, sure. Yeah, you could just talk to the camera's relative offset directly. You could drive that by way of any input you like. If you wanted it to be the mouse wheel up or down, that's fairly trivial to establish.
It's so easy.
Really trivial.
So this mechanic, just a simple use mechanic took a couple minutes to set up when I went through. It took a little bit of iteration for the networking stuff, because that's always a challenge. I know my programmers were like, hey, this mechanic needs networked. I'm like, oh god, I gotta do replication now. And that's, if you're not familiar with replication, basically when you perform an action on a client, certain properties need to go to the server, so the server can tell all the other people playing what's happening. So player position, health, things like that, typical properties. You can't send everything, because the server will get overloaded and no one can play online games if that was the model. So you take select things, usually in variable form, and you say like, all right, here's client zero's player position, and now all the other players know every tick where every other player is, for example. Another component with blueprints for this game in particular, that's the way we've leveraged it the most is probably through our animation and communicating with the animations, and that stuff is ridiculous, and I'm excited to go through that. So you can see just kind of like how the character changes based on what I'm doing and kind of the attacks, because our game's a sword fighting game. It's extremely animation heavy. All of our combat mechanics are heavily predicated on the animations working while being fluid, and a lot of them use things like root motion to control like dashes forward, or they control the steps when you execute a combo. And all that stuff is, most of it's handled without code, and it's handled through Persona, which is Unreal 4's animation system, which really is an extension of blueprints. And that allowed me to sit there with no programming experience and set up things like, oh, I'm in water, so now I'm swimming. And being able to set that up in a couple of minutes versus having to have a programmer go in and say, all right, here's how you interact with swimming volumes, and here's the animation state for it. Or in UDK, I guess you could set up an animation tree by just using like a blend by physics and saying like, hey, you're interacting with water, so play this animation now. UE4 switched that up quite a bit with state machines and kind of the animation system. So the first magical thing we're going to is blend spaces and kind of the basic animation stuff. So they basically, before you would have to set up arrays or different things, so this plays straight into Blueprint. And basically you can have either one axis or two axes, and you can set those to be any property you want. So this is kind of the easiest example. Is basically I set up pitch versus yaw to set up your aim offset. So when the character's aiming around, he animates based on where the mouse is moving. And basically these properties, when you put them into your anim blueprint, it gives you the nodes to just plug in whatever variables you want. So you can grab where the mouse is moving on X and Y from code with a blueprint node. There's a big get aim offsets function. Plug that straight in, and basically the functionality gets set up exponentially faster than if you were to hard code the aim offset. This is one example. This is something that we also use to do directional runs. So very easily, we basically just have direction versus speed. And at 0, basically you drop animations into this graph. And all these points are different animations that are just looping animations or whatever your particular setup is. For this one, they're just an idle cycle. And then basically it determines your direction. The way we did it is in code, there is some back end. Our programmer set the system up so we could do the blend spacing right. Basically he declared all the directions 1 through 9. Each number, like 1 is, or like 5 is forward, and I think 1 is back. And basically it allows us to easily set, he calculates what the direction is, gives that node to me, and plug that variable into the blueprint to basically change what the run animation is, which is super powerful. The same thing kind of applies to any of your states. Let's see what other ones I have. This was the same thing that we used to do the sprint mechanic. Is we just had a very simple, it looks for at like 300 speed, which is like kind of the default movement speed. You're playing your normal run, and then it calculates when you press shift, all of a sudden it doubles your speed and it plays a different animation. And the great thing about it is it blends all the in-betweens, which maybe for runs isn't super practical, but for directional runs, for sure, you can get those smooth blends when you're changing direction, where you're not having to make so many animations. And that's really the power of this system. It cuts down the amount of total animations you have to make for your game like tenfold. Like there's so many animations that we don't have to make. Where you have to make like little in-between transition area animations, you don't really have to using this system, because it just picks up kind of the interpolations between one animation to the next. Using blend spaces is one way to do it. So into the actual anim blueprint. This is really similar to animation trees if you've used UDK before. If you haven't, I don't really see if I can put it in other terms. Basically, you're visually representing your game flow and your game logic. You're looking at, here's all the actions players can take, and I'm figuring out what animations need to play at those times. So it's kind of smoke and mirrors in a way. You're setting up, you're saying like, all right, the person playing gives a certain input. What is that action? So if you're holding W, for example, you're moving forward, but what actually is that? You're translating forward in space. But to present that, well, obviously you've got to play a movement animation at some point, a movement cycle, walk cycle, or run cycle, or whatever. And basically through here, you're setting up the logic for that and saying like, here's the flow of how things happen. Like, here are all the possible actions that a player can take. And you're setting up kind of the structure. So there, one of the new things in Persona that's way different from animation trees, where you just have this giant web of logic, is state machines. And ours is pretty complicated, and I'm not an organized person, as you can tell, so there's just nodes everywhere. It makes sense to me, and I'll break it down. Basically, how this works is this looks at, basically, you're setting a web diagram of your mechanics, and how those mechanics play with each other, and how you can transition from one state to another. So the best way that I think about this is I wrote down, here's all of the actions my player can take that requires an animation. And from there you set up a state. So the first state when you first spawn in is going to be an idle state. So from in there you kind of have like a sub. This basically you almost have like mini animation trees like built into each state. So from in here, there's some extra stuff I'm not using, so ignore that. But it goes to this node, and basically this is just, there's a stances variable here. We have two stances in our game. It's kind of an alternate. You have like your default, like your light stance, and then like your heavy fighting stance. And based on what stance you're in, it determines whether it plays like the alternate stance idle or the regular idle. So you can kind of see if I pop back in game. If I close this window, there we go. You can see how this is controlled just by those few nodes of switching between the idle animations. And this pretty much happens automatically because the variables kind of linked up. I'll show you where that's going. So this is where you've got to get a little more logical with it. The event graph, this is, again, very unorganized. At some point I'll have to do a pass for that. This is where you have all of your variables that interact with code or with your other gameplay blueprints, and you're basically passing all that information to variables that you can use to drive animations. So to try to break this down a little bit, just a few of the things. From here, basically you're accessing the character blueprint, and it's looking into that blueprint to see what properties it has. And I can basically like drag out, and if I drop down variables, I have this huge list of basically anything. So I can grab like what his health is even, or what his material is, or like with the character properties I can look at like pretty much anything. And from there I can use that information to make the character do whatever you really want him to do. So I'm grabbing out from here and I'm saying like get his movement direction, so then you can tell this is the 1 through 9 I mentioned earlier. This is telling the anim blueprint every tick, like hey, are you 1 through 9? Are you moving forward or are you moving back? And it updates the variable based on that. And then from there I can tell the state. If I go back to that, if I go into the moving state, I just drag and drop the blend space straight in, and this is how it's represented. You drop in the blend space and it has a node. If you remember from earlier, this is the direction versus speed that I had set up on the grid. And it gives me input nodes for that. But basically I grab the speed variable, and this is the movement direction from the event graph. So every tick, it's looking at where am I moving and how fast am I moving. And from there, it moves basically a point on that graph that I showed you from the blend space. It moves it to the appropriate point based on whatever those numbers are, which is freaking amazing, for lack of a better explanation. And the same kind of thing exists for basically all the other variables, like the aim offsets I was mentioning earlier. It's from here. And it's actually looking at what weapon you have to kind of determine how the stance changes and how that's affected. Movement speed. Basically all your states are in here. This is where where I'm setting up meditation and jumping, and basically show you how this ties in terms of a certain mechanic, kind of simplified. You go back to the actual character blueprint. First off, does anyone have any questions while I'm bouncing around? Or is anyone completely and utterly confused? Are you guys following along? You guys are going to go home and make awesome blueprint games tonight. So this is literally the meditation mechanic in the character blueprints. All it is I set up a variable here. You can literally just click variable and just set up whatever you want. And basically, it's just a toggle. It's like you press the meditate key. If you're already meditating, it makes you not meditate, it makes you get up. And if you're meditating, you're not meditating, you drop into meditation. Basically, it just swaps back and forth. I can pass this information back to the animation. So when I go back here, basically I grab that variable from the character. Basically I use this node as kind of a catch-all to say like, here's all of the things that I need from my character to drive animations. So I accessed the meditating variable and I basically synced it up with a local one within the animation tree, or animation blueprint, excuse me. So basically it synchronizes from one to the next by passing that information. And how I use that in state is, actually I have a meditating state. And in here, it basically just looks to see if meditation is true and at what point it is, and then it just plays the animation as is needed. So when I go back in game, I just press and I go into meditation, and all the information syncs up. It knows to play the right animation, and I press. Basically, all the input's doing is just switching a toggle, true or false. It's like, oh, it's true now, and I press it again, now it's false. And all the other things are kind of synchronized by passing that information back and forth towards different blueprints. And this is stuff that previously it all sit in Unreal Script or in C++ or whatever. I mean, maybe you can Kismet or the animation tree and you can even do some of it, but not every game engine has that functionality. A lot of times you're having to hard code, like, okay, are you meditating? Okay, now play these animations. It's all hard coded in if statements, and it gets really complicated. And if you don't program, then you can't set that up on your own. Here, you drop a couple nodes in, press a couple buttons, and it works basically. Which it's lowered the barrier of entry for indie developers and students to start prototyping. You guys can get your games out way faster and start playing with interesting mechanics. Like, if you have an idea in your head, more than likely it can be made in Blueprint very quickly. It might be super complicated, take some time, but as far as the early prototypes. So the magic here, besides just having individual states, is like the transitioning in between. So I can preview kind of the changes of variables here. If I just click, you can see like how it lights up and changes. And what all these crazy little nodes in between, what those are handling is basically what rules need to occur to go from one state to the next. So basically, an example of that is you see what's highlighted. What's highlighted is the active state, and it tells you what percentage. So for prototyping your states to make sure your rules are set up right, you can really quickly debug. And you can actually, when I'm playing in game, you can drop down and pick your character, and it'll tell you real time what state you're in, which is, if you have dual monitors, it's great. You can slap the screen on the other screen, run around with your guy, you can see exactly what states he's going through and when. So the first example is basically you're idling, but the first action you're probably going to take as a player is you're going to go to a moving state. So what happens there is basically in here you're looking at the rules, and in here you're visually setting up the logic for going from one state to the next. And these are things that for sure were sitting in code before. And now you're just throwing in nodes. You have a list here, like basically I have a variables list below that has all the properties of the character that I set up. And in here, basically saying what can be true and what can be false to be in this state. And it's basically, to boil it down, if you're moving faster than 100 and you're not doing any of the other things, then you're moving. So when I go back to the state machine and I change my movement speed to 300, it automatically knows to transition me to moving. And then in there, I basically just set up the blend space, drop it in. All right, here's all my running animations and the directionality and all that. And basically between those two actions, you're setting up directional runs for your character, setting up idling for your character, and transitioning into movement. And not just forward movement, but any movement. Because as long as you're moving at above 100 movement speed and you have a direction, your character is going to play the appropriate animation. And if you think about that, you can kind of see the possibilities that are there, not just for movement, but for any actions that your character might take. So any questions so far?
You mentioned earlier that, you mentioned connecting your game with using network connection. Is there a tool in the new engine for network connection, or is it still scripted?
In what terms, as far as connecting to a server?
Yeah.
Or as far as I know, it's built in. I mean, I can do, when I do play from here, you can literally check and run as dedicated server. And you can say, like, open two clients. When I click play, it's going to open two windows. One, the window behind this is the actual server, and then this is a client. Because a lot of times, when you're setting up scripting for networking, it's going to work on whoever's the host. Like if it's a listen server and you're playing and you're also the server, most of the time the things you're doing are going to work. But then you run up on this. If I was to run up on this client, the client might not get some of that information. That's usually like how we figure it out. Because I'll go in and I'll try a bunch of stuff just locally in the plane editor, and it works fine. And then I run a client, and I run up, oh crap, none of this works. Forgot about networking. And blueprint variables have a drop down for replication. You can say literally rep notify this variable or replicate this variable. And basically, if I go back to the character blueprint, I can kind of show an example. So this is an example of a networked mechanic in Blueprint. I'm going to set up the use to replicate. I'm not sure if use even needed to be replicated. I didn't check with my programmers on the logic. I just did it at like 1 in the morning one night, and it worked, so I was happy. And basically, there's this rep using event that you can say, like, all right, you're pressing this, and this is going to pass to an event that is replicated, and that gives you basically this connects to this node, which is basically, this is a function that you translate into an event. So every time you press use, basically it's like, this is passing to the server, and then from here, this is like the server is executing this, and then what are you doing? So basically you're plugging in what would happen locally. This is setting using to true or false, and it's doing it through a replicated event, if that makes sense. And for some other examples, I'll have to put bots in and kill them. But we set up our health, basically our character desaturates in his material as he's taking damage. That's one of our feedback mechanisms for when you're losing health, because we don't really want to have a lot of health bars and stuff like that. We want it to be a very organic experience. So this is just a really simple, it looks at his current health and what his max health is, and there's a little formula that we came up with that based on that, it changes a property in a material. So if you think about the power, you can use that for anything. If you wanted to destroy something, if you're on my first panel, and you wanted like cracks in the material to like grow up the column before it explodes or whatever, you could just have a variable that at 0 it turns the cracks off, and as that number nears 1, it's like turning on the cracks that are crawling up. You can control that from Blueprint completely with events. You could literally just grab an event and just do like when something's taking damage. Like if I had the column here, I could do it right now, and it would work actually.
I've got a question.
Yes.
This looks amazing, fun and simple, but what happens when you have a team of people working on this? What about source control? What about inefficient, an artist did this great thing and it looks great on a single client, but like you said, your examples are rather unorganized. How do you test, how do you QA, how do you source the whole thing so that you don't have a bunch of crap in your game?
The first thing is version control is built into the engine. I don't have it activated in this version because I don't actually dev on this laptop, but there's actually, if you would see down here, there's source control built in. It integrates into Perforce, and I'm not sure what other ones. It might plug into SVN or some other solution. But Perforce is kind of the industry standard for source control, as far as I know. And that's what I use for this game, and I use it professionally in my day job as well. And basically, I mean, since files are checked out, there's not overlap as far as like people crossing streams and working on the same files. It locks them out from everyone else when you're working. As far as debugging, I mean, really, organization is just on the responsibility of the developer. It's my responsibility to go back at some point and organize that in a way that if another one of my team members needs to work in it, it's set up in where he understands what I did, or I understand what he's doing. I mean, this particular blueprint is set up more organized. It's commented on what each section is for, what it does. And as far as debugging goes, let's see if I can show it on one screen. It might be a little difficult. But you can do your debugging real time. So you can see how it says simulating here. It'll actually light up events that are firing while you're testing. So on dual screen setups, it's great because you can drag this over, set your debug setup, and I'll see if I can show both. Or I'll see if there's something that fires. It might not work in here. But usually, if you perform an action in here, and it takes place, you actually see like the little lights like shooting down the splines, and you'll see the actual like, updates of your debugging. So you can see if there's a breakpoint or there's a point in your event where it doesn't get passed, you can see why like your mechanic's not working. Let me see. I really want to show an example of that because it's a really great system. Because before you'd have to use like a third-party debugger, or you would just kind of have to keep trial and error until you get the result you want. Whereas here you're visually seeing exactly what the problem is, or seeing if your mechanic's working.
I think they allow you to set breakpoints in Blueprint.
Yes.
Okay. So you can just kind of get to a certain section and stop.
Yeah. So let me see if I can get change something quick. Zach might have more elaboration on breakpoints. I'm not
Sure.
like I'm pure artist for the most part.
If it helps. So to see the simulation in Blueprint, all you need to do is set your what object you're actually following, which you can do up in the toolbar. Setting a breakpoint is really just right-clicking on a node and telling it to set a breakpoint. When that node fires again, it's going to pause your game and jump you right to that node in your graph. I'll be happy to show folks after this demo if you'd like to see something.
Yeah, and what Zach's talking about is like from this dropdown, I'm running the game in the background, and let's see if I can get this. You can see how it lit up idle. I'm gonna try to see if it'll let me. You see how I'm moving in game and it's updating what I'm doing. This is like real-time debugging essentially, and the same system exists for the other blueprints that we were mentioning before. I can't see where I'm going, so it's a little bit difficult. I'm gonna try to move this time. Yeah. So you can see like as I'm changing my action in game, it updates real time in the actual blueprint editor what action is taking place. So you can see your transitions, and this was super useful because this diagram got very confusing very quickly when I was setting up the mechanics, and a lot of them weren't working. There are instances where like I'd jump in water and I'd still be playing the swimming animation, or I'd get out of water and I'd be swimming on the ground because it wouldn't transition back to the movement. And basically using this particular debugging method in the engine was the only way I could find out. And I found it, I could see the point that it was getting stuck, and it had like, it breaks down the percentages. It might be hard to see on the screen, but you can see it says like 100% active, and you can see percentages changing as I'm transitioning in states. And you can set up the blend times for that too, how long it takes to transition, so you can make it more smooth, or if you want a rigid cut to a different state. Let's see. And the swimming state had no back end from programming, for example. Like this is the swim states were things I set up in a couple minutes with Blueprint. And there was already functionality that could look at what your physics state was, and there was already a volume that would tell the engine like, hey, you're in water. So basically all I had to do was say like, set up a Boolean that says be swimming, and when it's true, just go to a state that I made that plays an idle cycle of swimming. or a swimming cycle rather. And then if I let go, but I'm still in water, then there's a swim idle instead of a normal idle. But being able to debug that real time is kind of ridiculous. And you see, like, there's some transition smoothing that I could probably do here, where you're kind of on the cusp of getting out of water and it doesn't quite take you right back to movement. I can look through here and see how the percentages are breaking down and tweak the rules based on that. So I might find that as I'm transitioning to the swimming state, one of these rules isn't correct. Or maybe I need to add more booleans in here of different things, because maybe you're holding the sprint key while you're swimming, so it thinks you're in both states. So you have to kind of break it down from there, for example. And that's just like a practical example of kind of the debugging. The blueprint specific stuff that's pure mechanics and not animation, the principle still applies there. So any questions about any of that stuff, the animation system or blueprints? Yes?
How has importing your animation loops changed at all?
The first change is when you import a skeletal mesh, first it breaks it into a skeleton. So let's see if I have an FBX I can import from somewhere. As it turns out, I do. So I'll just import something. Basically, it brings up this dialog and it asks you whether it's a skeletal mesh or an animation, which is nice because you can kind of. And then if you don't have a skeleton, it makes one for you. So if I just click import, it's going to split a skeleton out, which has all your bones. And this is in UDK. This is basically the same as like the old skeletal mesh editor, except way better interface. And basically all of the things are better. Was you set up your sockets like you saw in the last one to attach weapons or attach a particle effect or whatever. As far as importing animations, it's the same process. Basically what it does when you import, you declare it as an animation and it asks you what skeleton you want to apply it to, which is awesome because in theory you could have an animation that you import to multiple skeletons, and if the bone names and the positions are close enough, you could basically reuse animations on different characters. And there's actually retargeting systems where, like, say, like we have two different skeletons for our two characters, because one's like a little bit shorter, disproportionately bigger. So we have like the archer character and then like the swordsman character. We could, in theory, take like the animations from the basic movement animations, retarget those to the archer skeleton, and start reusing those animations. So this was particularly useful for my team because we have one animator, and it takes a long time to get all the basic movement animations. Because these are basically, all these animations are all of the cycles for movement. And through blend spaces, I set up a couple of different setups, or maybe 3 different setups that drives all of these. But these animations exist in the anim blueprint, in blend spaces where properties are driving them, rather than you having a hard code like, all right, you're moving back and I'll play crouch run B because you're crouching and moving back. That's just all handled for you, basically. So while I'm waiting for run animations for my animator, I can just retarget things from the first skeleton and have it be something to prototype. So I'd say prototyping above all else is sped up so quickly that, I mean, plus with all the sample content, like Unreal's Marketplace, like one of the companies released a good pack, like 50 characters. You can just download it, they're fully rigged, fully animated, you can start prototyping mechanics in an hour. And you can leave and go get your laptop out and make a game. Yes?
In terms of you guys' characters, I saw when you were pulling up the animation, do you split your animations for each FBX file, or do you like create just one FBX and put all your animations into it and then import it there? I know you can have like multiple animations within one FBX file and then try to import it in and cut and paste it all in Unreal, or do you need to have each FBX be a specific animation?
I believe you can do both. We have so many little cycles that we split them. We have a max file for each animation and a different FBX for each file, but I believe you could probably put just all your animations on a giant timeline and just have a record of your frame ranges for each animation. 0 to 10 is this, and 10 to 20 is that, and you could just declare that range for each export for organization's sake, I wouldn't do it that way, but it's really just personal preference. There's not really a wrong way to do anything, assuming that it imports right. But as far as I know, I mean, either one's viable, but it just depends on the scope of your project, who you're working with. And since I'm handling tech art for Hanukkah, my animator is just putting FBXs up on Perforce, and they're named what they're supposed to be named in game, and then I just import them in mass.
Now, is the overhead, I mean, because for each FBX that you have, it's the exact same character. So is the overhead just like size? Like, I mean, if you have like 50 animations, you have 50 FBXs, all with the same character, and instead of having one FBX with one character, just a whole lot of animations. You know what I'm saying? Like, is it a lot larger? Because the game comes a lot larger?
The cost is the same because you still have one character and one skeleton, regardless of because the end result's the same essentially. Even though you have like all your animations in one FBX that you're exporting separately, when they import into the engine, it's still going to be like in this list the same way. And basically, it's the animation isn't specific to a character, but it is specific to a skeleton. So basically, it's playing the animation on the skeleton that's inside the character, and you could use the same skeleton for like an infinite amount of characters. You could have 20 characters that use the same skeleton, and all the animations will work on all of those characters. So the cost is irrelevant at that point. It's just the cost of like the singular animation. As far as like you're not paying the cost of the character for each animation. It's not like having to load the character mesh and load the skeleton and then load the animation for like each FBX. It's just a single load for the character and skeleton, and then the animations are the only cost. We'll go through our so for Hanukkah, we have a lot of custom systems as well that aren't completely dependent on Blueprint. We have two programmers that prefer to code in C++, so we do have quite a bit of code as well. And at some point, actually, when I was going to do a stream, I'm doing like C++ stuff from scratch for Unreal 4 stuff. That'll be pretty cool. Did any of you guys attend Zach's workshop yesterday? Yeah. There were lots of learning in there. But basically, for our combat system, we have directionally driven attacks. So it looks at what direction you're moving when you click, and it plays the attack that kind of corresponds with that. If any of you guys play like Jedi Knight 2 or Jedi Academy, any of those games, very similar to that setup. I love that game, and I still think that's the best like, sword fighting melee system in any game period. It was super fluid and like really intuitive, and I wouldn't say we're basically trying to create that kind of fluidity because melee games now like Chivalry or like Warcraft, a lot of those Mountain Blade titles are super slow combat. It's not very realistic. It is very gamey, and I don't think they're bad games. But as far as like what we're going for, I don't think like really clunky mechanics play to like the samurai theme very well, where you're like basically like waiting for a slow motion attack to finish so you can react to it in time. I want this to be a little more visceral and exciting, kind of like how Jedi Academy was crazy duels with dudes running around. So maybe some plots in here. Yes.
How does the system handle an incomplete transition? Say, for instance, that if you wanted to go from, and I don't know whether you did that in Animator or in like if you were like in the middle of a swing, but you stop it, and you go to block. Like, I don't want to go from like, I have to play through the entire animation just to be able to transition. Does the state system handle those percentages like that too? Like we're doing a partial transition and then go a different way?
Yeah. At any point during a frame, if the rules necessary to transition occur at any time, it'll just transition. You do have some control over that, and there's blend properties that you can set a time, the amount of time it takes to transition. Usually it's like a couple tenths of a second. Most of ours are like 0.2 seconds that it transitions, and that's how you get the smooth transitions between, even though I'm spamming keys right now to change direction. If you look up at the screen, I don't know if you have a good view angle from where you're sitting. But basically it's calculating every tick what rule needs to occur for me to change. And if you see I'm attacking and then clicking block, you can see how it doesn't quite play the whole animation. Like, this is the whole animation. But if I click and then click block right away, you can see how it kind of snaps to the block, which potentially you might run into a lot of transition issues where you get like really bad transitions, but the engine gives you full control over that. It's just a matter of going back and tweaking your blend times. If you have blend in and blend out, where you have full control over those transitions, and you can really just keep iterating on your rules until you get kind of the ideal. Does that answer your question? Okay. So for this system, our attacks are based on the weapon and the characters. There's 4 classes in our game. They all have 2 weapons to choose from, and then an alternate stance for each. So setting that up was pretty heavily code-driven because it's custom behavior. So what we do with our blueprints is we integrated the directional attacks in the actual weapon, and that communicates with the character. So in here we set up properties that basically set up what animations it plays for certain custom properties. And it's probably easier to set it up in Blueprint, but when you have programmers at your disposal, they want to code, so I'm not going to deny them that opportunity. And it's their belief that, Zach, feel free to correct me, it's their belief that coding in C++ is more efficient and easier to control like memory cost and the overall cost of your game through C++ rather than blueprints. Is that true, Zach? Or is their presumption incorrect?
I mean, it depends on who you're talking about. Some folks think that way. I mean, Blueprint at the end of the day is a scripting language, so at a really, really, really rough estimate, it's about 10 times slower than native C++ code. So it's really what you need and when you need it. If you're doing something that's really, really banging on the CPU, then you should be coding in C++. But the animation system is not the kind of thing that a programmer would ever want to touch. It's way too artistically driven.
Yes, that is why I interact with it, and they usually don't. They actually hate interacting with it, mostly because it's unorganized, but also because they're like, it's visual, you can do it. You're an artist. But there's a lot, like you see, there's a lot of custom properties that we set up. Like we have kind of our stances, and within here, you see it has slots to plug in all the animations. And basically, I have a document that our programmers made that say like, here's what all the attack directions, what number they correspond to, and then I can come in and plug in the animations for each. And then there's also the animation blueprint is splitting our character in half. Basically, you can play different animations on the bottom half of the body and the top, and that saves infinite amount of time. Like not infinite, but it saves. I can't even explain how much time it saves. How many total animations, like your total animation set per character, how much time that saves. Because before any blending stuff, you'd have to hard code that behavior, or you'd have to make an animation like, all right, I'm swinging in place. Now I'm swinging while moving. Now I'm swinging while moving this way. You have to have a different animation for all of that. In this, you just say, no, play the movement animations on the lower half of the body, and then play the attack animations at the top. And I mean, that exists in Unity too, but you have a little more control over it here. It's a little bit easier to configure. So with that said, we have 12 more minutes. I'll touch on some visual artistic things too, so I'm sure there's artists in here. So artist people, raise your hand. Yes, lots of artists. One thing I'll comment on, I don't think I have speed tree installed, but the new speed tree for UE4 is probably the coolest thing of all time. Our game's so nature-based and it's such huge outdoor levels. Being able to create awesome trees in a couple of minutes is kind of along the same. It seems like the general theme of Unreal 4 is efficiency and getting things done timely and working smarter rather than like beating your head on old outdated methodology for making games. They've made everything streamlined, everything simpler and easier to do, and easier to pick up. Yes?
Is there like a shader tool?
There's the material editor, which has gone with more like a physically based system. I'll show you. The material editor is very similar to the one from UDK, or even the Slate material editor in Max. It's still like their base materials. And one of the great things, a lot of plugins, if you use like Dedo or algorithmic surface painter, is it surface or substance? Substance. The program's called one of those two things. Basically, with the physically based rendering model that's becoming popularized in games, it lets you export material straight to the engine now. So instead of having where you have like your diffuse, your spec, and your normal map, and you import it, you set it up, and you set up your materials with masks or whatever in Dedo or the substance painter, and then it just exports the material, and your material's set up in engine with like metal looking like metal and like rubber looking like rubber or whatever, plastic, and everything reads how it's supposed to. But for our game, we went with a little bit of like a mixture of the approach because we made these characters originally in VK. They had the old setup, diffuse spec normal, and a couple other little tricks. We wanted to have some of the new things too, but you know what you're targeting for your final platform is important too. If you're making a mobile game, obviously you can't have like full PBR on everything. It's like 200 instructional materials for like all of your assets and all of your characters. So you kind of have to scale based on what you're making. Which the new version actually is like you pick your platform and it tunes like all of your settings for it, which is going to be pretty sweet. I'm excited about that. But like they changed the way specularity works in the new engine, where before you would just have like you just paint like white or a really bright color in your spec map. Like, all right, that's metal, I'm done. Now that handles how non-metallic surfaces work, and basically you're setting up different blends. So if you look at this, for example, this is using like sub-materials in a way, they call them material functions. But basically I'm setting up a specific material. I'm saying, all right, I want a certain part of my character to look like it's gold. So they control that now with the metallic property. And basically 0 is not metallic at all and 1 is like super metallic. And you can see like how the preview is actually pretty small. You can see how the lighting changes and you can see kind of how it looks metallic. And then you have roughness properties as well. That's where you can kind of, if you have a mirror and you want it chrome, you could use a texture that just has like the random dirt or whatever. And then in those spots, you wouldn't get the reflectivity as much as like the clean spots, for example. And in the new system, you kind of set up, here's gold, and then when you have the node in the master material, which holds everything, you're dropping in the material function, and you have like the node, very similar to Blueprint in terms of the visual scripting and like the node-based setup. So like the properties I set up here, I can change like how metallic the gold is, how rough the gold is. And basically, it has an alpha channel where I make a texture where I'm saying, wherever I painted white on this texture, put gold there. Wherever it's black, just put the rest of the material. And we're doing a few layers of that here where I'm basically using an RGB mask because that allows you to have 3 masks in one texture. I can say wherever I painted red, put gold. Wherever I painted green, put like chainmail. It's a little bit metallic, but not as much as gold. Wherever it's blue, just put like a general like lacquered wood look or whatever. So you have kind of full control over what material appearance goes where. But the magic there is before you'd have to do like different material IDs, which is a different draw call per material. So you're getting this from one material, but you don't have to pay the extra cost for doing that. So yeah, we have a couple minutes left. Does anyone have any questions or anything specific you want to see that you haven't seen? I didn't get through a lot of artistic things. I went very blueprint heavy, but if you guys want to see something specific or have any questions, now would be the time. Yes?
Have you guys implemented any of the new destruction features?
Not in our game, not yet. That's funny. I did a panel destruction before, and I was asked, like, I knew I was going to get asked about destruction. Like, this is the one thing I haven't played with in this. For a multiplayer game, I wouldn't say, I guess in a general sense, you can't really pay for physics on all the clients all the time. So if you have a lot of, you can probably have some destructible things, but if your level is full of them, and everyone on the server needs to see that happen, and you're calculating physics for every chunk of destructible stuff, every frame, like it's just not reasonable to have a well-performing game. The system I went through before, if I had a couple more minutes, I would just import that column and do the destruction setup. But what I recommend doing is doing a pre-canned, just doing your destruction in 3D Max or Maya, and basically rigging your model to play a destruction animation when it needs to. You can use Blueprint and just say like when this takes damage or when this gets shot or when I headbutt it, fall over. And basically it's kind of sleight of hand. You're not really technically destroying it, you're just making it seem that way by playing an animation when you do a destructive action. So for multiplayer, that's how I would personally do it. If we do destructible stuff for Amico, I'll do it that way.
How hard would it be to implement just like I know in Knights of the Old Republic or Jedi Knight, Jedi Academy, you know, the kill guys armor and then just fall. You know, how hard would that? Just do that in like Maya or?
For that, you can do giving and stuff like that in the engine. I believe there's bone breaking options where I haven't done it yet, but I'm confident in I know the system's there. It was in UDK, and I'm sure it's probably better in UE4. You can define a bone. So if I define the shoulder bone, I can define it as a bone that breaks, and you can probably use blueprint or code or whatever action to say, like, hey, if you take damage around this spot, you can probably put like a collision capsule in this area. If that gets hit for a certain amount of damage, then the shoulder bone breaks, and like everything that's weighted to that shoulder bone down in that bone chain, in theory, you can make that fall off and animate, or say like, hey, ragdoll now on this spot. So like ragdolling and physics assets and doing that kind of stuff is reasonable for most. That's what we do when you die. It has like physics boxes for all the limbs, and it simulates like the dude flopping on the ground or whatever. And same thing for basic physics. You want to kick a barrel around the floor or whatever, or have things that are interactive. You can still do that. I mean, it's just basically a couple check boxes. Yes.
It's been an art question, but do you have any concerns with Unreal 4 on Mac systems? Or do you have a comment about running them on Macs?
I mean, I think as long as the hardware is fine. Zach would probably know better. I've never used Mac for anything.
Well, yeah, that's what I was asking.
The performance will be a little bit lower. That's because of Apple's implementation of OpenGL, and there's really not a whole lot we can do about it.
Okay.
We have seen some improvements on their new OS. It's not quite where we want it to be, but it's really, the onus is kind of on them to handle their OpenGL stuff a little bit better.
Yes.
It's totally usable, but you won't feel the same performance that you would feel on a similarly built Windows machine.
Gotcha.
So yeah, does anyone have any other questions?
I was kind of curious how this all translates to 2D game development.
Into
2D game development?
there's a ton of templates I mentioned earlier in the panel. Epic put out a bunch of awesome templates that basically, it gives kind of the basic mechanics and structure of your game set up for you. They have side-scroller templates that you can download it's technically 3D assets, but they have the side-scroller camera configured. You can kind of set up your game from there. And I believe, what's it called, Paper 2D?
Paper 2D, yeah. I'll be demoing that at 2 o'clock in my session, so if you want to see that, you should drop by.
So 3D physics simulating a 2D game.
In Paper 2D, or if you're doing like Suda, if you're doing a side scroller but it's still in 3D, and it's a 3D game but you're using a 2D camera, for sure you could use full physics. And I believe I read an article recently that was talking about constraining it to like a side scroller space, for example. There's ways to do it for sure. I'm not 100% sure how I would do it if I had to make a side scroller, but it's possible.
You could probably pretty easily render an image, just display it as a flat object facing the camera.
But yeah, does anyone have any other questions? In closing, I'll just say that if this was interesting to you guys learned stuff, I stream development almost every day, every night usually when I get home from work. If you guys want, I'm always doing Unreal 4 stuff and modeling. And basically, with Hanako, it's an indie project, and I put a lot of my free time into it.